right, in this lesson, we're going to talk about pumps and try and get you some basic knowledge of pumps so that you can go ahead and make some decisions about your rainwater harvesting system. So the first thing to know is all not all rainwater harvesting systems will need a pump. There are definitely instances where you won't. For instance, lots of garden irrigation systems don't actually use a pump, or if your water's at elevation, you don't need a pump. But most of the time, to get the most out of your rainwater, you'll want to include a pump. And the kind of questions you want to be asking yourself, the first one is, how much pressure do you need? Know that the residential code usually requires 45 psi, or that's 300 kPa. And Peter, is it the same in Australia around there?
Um, well, yes and no. It's probably a good time to jump in and say nobody really knows what the correct design process is for pumps, certainly not in residential codes and so on, because like we've talked about elsewhere in this course, the design guides for pumps has been taken off the mains water utility water industry without thinking too much about, and the swimming pool industry, which was without thinking too much about what's really required for pumps. So in the rainwater harvesting system. So a key principle for a pump in a rainwater harvesting system is not peak flow rate, it's actually transfer into the home. So normally the specified pressure ratings for pumps in codes are more than enough for a rainwater harvesting system. But as you can imagine, if your rainwater harvesting system is supplying, say, the second or third floor of a dwelling versus a ground floor, it's applying water efficient appliances like low flow toilets and washing machines, which I hope you've all got, versus older high water using appliances. You get actually different requirements for pumps. So,
like one of those full body showers?
yeah, the elephant washer. So they will take as much water and pressure and flow rate as you want to give them.
Mm-hmm.
Please don't get one of those.
No. We're going to make some assumptions here as we talk about pumps, that you've used water efficient appliances, right? And you don't have any of these incredible water guzzling appliances, and you don't need them, right? So that's kind of the starting place from this conversation then?
I think it is. And the starting place for this conversation is actually not about the pumps, which is where people in the rainwater harvesting industry who are just starting out get a little trapped with conversations about pumps. Because if you go to the pump manufacturer or your plumber or your hydraulic engineer, they'll start with the pumps and end with the pumps. But as a rainwater harvester, your questions are about, how am I going to use this water and what appliances are using this water? So, for example, your toilet flushing, and I know in North America toilet flushing is a fair bit different to here, but we've got very low flush toilets, but you guys are catching up. Mm-hmm. And so your toilet doesn't need pressure or flow rate. It just simply needs to flush.
The tank
from the
needs
system.
To be full, right?
Yeah. So it's actually a slow top up in your toilet. So a high flow rate pump, if you're just supplying a toilet, high pressure, high flow rate pump, is a waste of energy, and it's fighting against your appliance, because you actually need a slow non-peak flow type top up for a rainwater supply into your toilet system, and that'll be something like 2 litres a minute, and I don't know what that is in gallons, 1 gallon a minute perhaps, or maybe half a gallon a minute, and you don't need any pressure. But say if it's say your kitchen tap, these days we're trying to make them flow a bit slower, so we use less water. But kitchen tap use is generally a volume-based process anyway. So if you're filling up your kitchen sink or filling up a saucepan, you actually want the volume of water, not the flow rate. Um, and you won't read this in much of the water efficiency literature, but we need to. Again, that's not a high flow rate um, process. If you have a water efficient washing machine, they only need 4 litres a minute flow rate, which is about a gallon a minute, I think. Michelle, I get these conversions right.
I've got it down here.
Here we go, conversion table.
Yeah. So the washing machine,
Here it is.
12 liters per minute is about 3.2 gallons a minute. So it's a quarter. You can kind of quarter the liters per minute to get gallons per minute.
So that table we've got there is the absolute maximum from, say, your washing machine. If you have a water efficient washing machine, it's the apparatus inside the machine is designed to use about 4 litres per minute, which is about a gallon per minute. And when you're providing higher pressure and flow rates to that device, it's actually just buffering it. It's people like showers that have got high flow rates, but around the world we're realizing that shower water use is one of the highest water uses in houses. We're all aiming for less than 9 litres a minute. In Australia, we're aiming for less than 7 litres a minute at the moment. There are lots of standards who say, the garden sprinkler and the garden hose needs to have a very high flow rate. I think we've got a plumbing standard here in Australia that tries to say you need over 25 litres a minute. However, in our design guide we created in Australia, for rainwater harvesting, we said that needed to be less than 15 litres a minute. Again, if you're watering the garden doesn't want a high flow rate. It just wants to get wet. So if you've got a lower flow rate, it's probably better for letting the rainwater soak into the soil and do benefit rather than just running off. But you'll be standing there longer with the hose if it's a lower flow rate. So I've taken you guys sideways here, but it's a key question. If you're choosing a pump, you need to think very carefully about how you're going to use water and what type of appliances you've got. And the other design process that's used by in people thinking about pumps is tending to add up all the appliances together and say, therefore you need this flow rate. It doesn't quite work like that either. Although it's feasible, you might have someone in the shower and the washing machine going at the same time. But it's not feasible that every appliance in the house will be turned on at the one time. So these are the things to think about when sizing your pump.
Whew, okay. Part of me wants to dive more into flow rates, but maybe let's hold that and get a little bit more into detail in a moment. So back to, you're saying the thing to understand is that you actually want to start with flow rates, understanding what your flow rates and what you're going to use that water for. Correct?
That's the first one, flow rate and flow volume.
And flow volume. And then when does pressure, like I said, the residential codes often require a minimum supply pressure. How does the rainwater harvesting system designer want to be considering that? Do some appliances not need that minimum amount of pressure in order to operate properly?
Well, it's a bit of physics here, Michelle. Flow rate and pressure are related to each other. So high flow rate equals high pressure. Lower flow rate equals lower pressure. So you can't separate the two. So that's important to understand that. So, however, there's only one other side of pressure. It also can equal kinetic energy. The height you can pump.
Mm-hmm.
So I think that's where the pressure rating becomes important, because if you're, say your pump is in the bottom of your rainwater harvesting system and you need to pump up 3 stories into your bathroom, I'm not saying that's the case, but just say it is,
Mm-hmm.
that's where understanding of pressure becomes very important, because you need to be able to deliver a flow rate, not very much, but in your toilet on the 3rd floor of your building if you're doing that. So you pressure becomes the surrogate for the height you
Mm.
can actually pump the water to supply your appliance.
Okay. External versus internal pumps is another early consideration you're going to want to be possibly deciding on um, if there's a certain configuration that makes sense for you, correct?
I think the this was quite a debate in Australia, where originally uh, majority of the pumps were external because they were more affordable, easier to get at if something goes wrong. They made a bit of noise, so people put, and they're in the weather, so people were needing to put pump covers on them. And here's a beautiful diagram that Michelle's provided. Um, so there was, requirements to keep them covered, to shelter for noise and shelter from the weather.
Mm-hmm.
Um, but their benefit is because they're external. All the components of the pump is easily accessible, um, for maintenance and management and so on. Um, so, whereas the next iteration of pumps in the Australian and urban environment was, let's just put them inside uh, the rainwater storages. The submerged pumps, as they're called, use more energy. They're quiet because and protected from the environment because they're inside the water column.
Mm-hmm.
However, they're notoriously hard to get at, to maintain and manage if you need to.
Mm-hmm.
Um, so the trade-off between the two different types of pumps is the submerged pump is quiet, um, it's protected from the environment, it's far more expensive, but it's also uses more energy.
Mm-hmm.
It's difficult to get at, to maintain or check on, or and so on. Whereas the outdoor pump, if you like, the external pump,
Mm-hmm.
obviously it's going to make some noise, which you could colour up. It's cheaper, uses less energy, you can get at it,
Mm-hmm.
but it's not necessarily protected from the environment. So you need to trade these things off when you're choosing pumps. And when you go and see pump manufacturers, depending on what sort of pumps they make, and you'll get all sorts of different messages. Both options have got strong benefits and
Mm-hmm.
some downsides.
Um, Something I noticed on this two diagrams that I wanted to ask you about, Peter, is on the external option. I see the Y strainer on the suction side of the pump, as we've previously discussed, to protect the pump. And on the submersible drawing, I believe these have integrated filters because they're actually in the water, right? And then there's a Y strainer located on what looks like the downstream side of the pump.
Yes, I probably should go into the details of those configurations. It's a
Yeah.
good point, Michelle. So if we start, as you've pointed out, with a submerged pump, if you take your little cursor down right there,
Mm-hmm.
built into these submerged pumps, who are always, they're more expensive because they're usually very high quality pumps,
Mm-hmm.
it is a strainer of usually 30 to 20 microns
Mm-hmm.
that strains water as it's sucked into the pump. One of the tricks of actually using a submerged pump is you got to realize they sit right on the bottom of your storage, so you have to somehow work out how to make them not sit right on the bottom, because if they are, they'll be in
Right.
the sludge layer, and I've had to annoy some pump manufacturers in my country about, well, you're getting worse water quality from the submerged pumps because they sit right on the bottom and they're sucking in the sludge. So in my own house, I put a brick in the bottom of the tank and I reinstalled the submerged pump on top of that, so it's raised up.
Yeah, just a couple bricks would do the job, wouldn't they?
Don't damage the bottom of your storage. But I've actually written a little blog about that here in Australia. I should send it to the people
send it to
in
me
the course.
and I'll put it in the lesson notes.
And the and some of the with it submerged pump manufacturers are finally stopped resisting, and they're putting little legs on them, so they sit a little bit up off the bottom. So as you go up into the body from Michelle's cursor there, the body of the pump, water's flowing through the middle of it, obviously, up the line. And this diagram's got a Y strainer before it enters the bypass device, because getting sediment in bypass devices will also make the valves not function as well as they could. However, it sort of defeats the purpose of a good quality submerged pump has a filter on the inlet, so you probably don't need to have that Y filter at top as well. So that's being very cautious, that design. And then obviously it's pumping water through the bypass device. So,
and just to go back, this barrel union, that's purely just an access so that you can kind of reach in, unscrew that, and pull your pump out if you needed to, right? It's a way to access that pump.
Absolutely, because you need to be able to reach in and unscrew that pump so you can actually lift the whole apparatus out. And the other thing to note, you're actually got electricity supply.
That's this one right here, yeah.
With the cord going into the water, so it's sitting in the water supply, and that's probably the other issue I didn't mention before. So you're mixing water and electricity here, so you need a high quality electricity line to power that pump. But they're easily delivered, and most pumps have them. If we move across to the submerged, not submerged pump, the external pump, you can see here water's drawn from the pump through the Y strainer, which is needed to protect the pump in this case, because this external pumps don't usually come with their own filter inside of them. Water's drawn into the pump and it's providing pressure, and in this case here it's actually got this pump diagram has also got a little pressure vessel on it so that it maintains pressure between flow events. And why that's important is if you just flush the toilet, say less than 10 litres water, certainly hope it's far less than 10 litres water. In Australia it's about 3 to 5 litres. It won't turn on the pump because the pressure in that pressure vessel will actually allow a flow rate to your toilet, for example.
Right. And without that pressure vessel, you can end up starting and stopping your pump and causing all sorts of issues.
Well, there's some tricks in using pumps, and the answers to inefficient pump behaviour is usually nothing to do with the pump. So in all houses in Australia at least, when plumbers install toilet cisterns, there's a little tap in the wall or behind your toilet cistern or near it.
Yep.
They tend normally almost totally close that toilet cistern, so that tap, so the flow rate from mains water, utility water, into the toilet system is a slow trickle.
Yeah, we have the same thing. I'll throw a photo of one up on the video.
So if you install rainwater harvesting for your toilet, you must fully open that tap, that valve, or else your pump will be restarting all of the time because it's actually trying to battle with that almost totally closed valve that works okay for the utility system. And you get pump restarts all the time that we call pump cycling, and you'll end up using a lot of energy when you don't have to, and you'll be annoyed by the pump turning off and on all the time.
Mm-hmm.
So people often say, I need to replace my pump, it's not working properly, when all they needed to do is realize what plumbers do in houses. And as soon as you change your toilet system from a utility water supply to a rainwater supply, you've got to fully open that tap that's in your bathroom.
Mm-hmm.
So just be aware of that.
That's good. Okay, excellent. So then, knowing the two difference between the external and the in tank option, do you have a preference, Peter, for your designs and for your systems that you
I'll give you
use?
my preference by a story. I
Okay.
had an external pump for years
Mm-hmm.
at my city house, and it worked very well. It was a little noisy, but most pumps in the industry until recently weren't actually rainwater pumps, and there are not many pumps that are actually being designed for rainwater harvesting. So be aware of that. So what's happened in the industry? Swimming pool pumps have been used in the rainwater industry, and they're not a good fit for rainwater harvesting. So I had one of those. It was a small pump. I think it was a 350 kPa pump, which is sort of what Michelle's recommended above there, and it's provided a maximum head of 30 meters, I think, and a
Mm-hmm. That's
flow
100
maximum,
feet.
yeah, a maximum flow rate of 30 liters per minute, but it only had one flow rate, so which can be very energy inefficient when everything in your house operates at very low flow rates, particularly toilets. So what happens with pumps? If they're always giving you a flow rate of say 30 liters a minute at full pressure, say 350 kVAs, even though your toilet system might only need 2 liters a minute
Mm-hmm.
and practically no pressure, the your pump is using the maximum amount all the time. Same for washing machines and dishwashers and all sorts of things. So that house didn't use much energy, but I found that compared to what it could be, the pump was inefficient. Then I got talked into using the submerged pump, almost exactly the same design as Michelle's showing us here. Um, it cost a lot more, used a lot more energy, worked very well. It was very quiet. Um, and I recently changed to an external variable speed pump,
From this
which,
original single speed type
yeah,
model that you had.
and took out my submerged pump. So this is over a period of 20 years.
Mm-hmm.
And in the 3 years I've had the variable speed external pump, which is now a very quiet model, very small. The company who makes it actually made the pump for rainwater harvesting. It's no longer a swimming pool pump. So if I flush the toilet and the cistern wants 2 liters a minute at close to zero pressure, that's what the pump provides. It only provides the energy and flow rate that the house demands rather than providing the same energy and flow rate all the time, which what traditional pumps do.
Mm-hmm. Mm-hmm.
Now, one more idea. In my farmhouse for the last 25, 22 years, we've had, it's been fully off grid, and it has a diaphragm pump, um, which is a DC pump. So it's not using mains electricity, utility electricity. It's using direct current electricity from a solar battery, and it has done for 22 years. It uses about 1/20th of the energy of the original city pump I have. The variable speed pump uses, half the energy that my original pumps used to. So the diaphragm pump, which I got from a ship, by the way, um, is very, very energy efficient, and provides a very constant flow rate and pressure.
Mm-hmm.
So that's a good device as well.
Hmm. Matt, let's talk just a tad more about control strategies because I know earlier in the course, there were some good questions of folks trying to wrap their head around this idea of control strategy. which is really all that means is you needing to decide how your pump will turn on and what signal is going to drive the pump.
I think this is a really good question.
Mm-hmm.
In a previous lesson, I
Mm-hmm.
talked about the simplest and most efficient, probably, and foolproof control strategy is simply when the volume in your storage is low, the using a water level sensor, um, it actually signals it it closes the um, it it doesn't allow the pump to work because the valve is closed, so it's not actually trying to supply um, rainwater. So you've just got mains water through your house if you've got a dual water supply. So those systems, when we were talking about that the previous lesson in bypass devices, the valve is normally open to utility supply. If the water level is higher and the volume and there's enough rainwater volume in your tank, those water level sensors actually close the valve, and what that means is when someone turns a tap on in the house, the pump detects a change in pressure, so it actually turns on
Mm-hmm.
and supplies rainwater to the house. So that's the simplest
Yeah.
type of device.
Mm-hmm. Mm-hmm.
So
And the pressure and the pump itself that you purchase from the manufacturer has the pressure sensing um, controller within it, right? And that's something I think a student asked earlier. How do you as a designer uh, add the control strategy to the pump? And I think the point there is that most of these off the shelf pumps um, are are designed so that they can sense the downstream pump, there's downstream pressure and turn on when they need to.
exactly.
Mm-hmm.
This new modern one that's specially designed for rainwater harvesting, um, it's got too much information, I suspect, which was good for me to play with. It allows me to decide what pressure that the pump will actually turn on and supply the house. You know, what change in pressure, um,
Hmm.
and rather than it being preset, which happens with most pumps you buy, they're preset.
Oh, interesting. Hmm. And I'm curious, do you set that based on a controller that comes with the pump that you're able to program? Is that how that particular pump works?
This new pump I've got,
Yeah.
I'll send you some pictures,
Yeah.
Michelle, is known as an e pump.
Mm-hmm.
Um, I can run it from my smartphone,
Mm-hmm. Okay.
and I've learnt to leave it alone.
Mm-hmm.
And I can also, it's got a lovely little
Mm-hmm.
display on it, and I can set, um, you know, pressure differential, flow rate,
Mm-hmm.
all
So
sorts of things
yeah.
if I want to.
Right, and then Wi-Fi enabled. It just goes to show how, this is changing too. The industry and what's available is really changing.
Well, it's even scarier than that. I can be
Mm-hmm.
in another country and it can tell me when my pump is turned on
well,
and how much energy it's using. Uh,
that's good feedback, though. That's good
yeah,
feedback.
yeah. Well, yeah. There's some funny stories around that, but let's keep going.
Yeah, I don't want to discount the option of a pump with a manual switch, though, either, right? Which is even actually the absolute simplest control strategy is that you have a big tank of water and you want to use it, typically for outdoor uses, where you would actually just go and plug in your pump. You could, that's we've Rob and I have our big outdoor rainwater tank is like that, where when we want to use water from that tank, I actually just plug the pump in and then the water starts coming out. That's what I use, right?
Yeah, you can do
Mm-hmm.
that, and
Mm-hmm.
I've got a friend who does that as well in his house because
In his house.
one of his rainwater or at his house
Mm-hmm.
is one of his rainwater storages is down the backyard, down the hill in the garden. Um, so he plugs in his pump and away it goes. But there's simple idea there, Michelle, but the pump is already programmed to turn on. If it once you turn it on and it's plugged in and there's no pressure on one side and there's water on the other side, it's actually triggering the pressure mechanism in the pump. It's triggering to turn it on and supply water. So you're plugging it in and away it goes, but it's already designed to recognise that there's a pressure deficit on one side, therefore it needs to turn on.
Yeah, but what about don't when you have those kind of single speed pumps and you're using that control strategy, you don't want to be like I'm thinking in the end where you have a garden hose, right, with say a handle, a squeeze handle. When I stop watering my garden, you don't want to just leave that pump on. That's one thing you have to be aware of, right? Because you could be possibly, if that pump doesn't have the right kind of internal control strategy, don't you risk wrecking your pump? Wouldn't it?
Oh, absolutely.
Mm-hmm.
Gee, that's a primitive sort of pump, Michelle. But
Mm-hmm. Mm-hmm. It was a cheapo pump.
so if you have one of those and you're not using water, you
Mm-hmm.
must turn it off because
Mm-hmm.
pumps cool themselves by water passing through them.
Mm-hmm.
And if they're just operating and you're not supplying any water,
Mm-hmm.
what happens is the water inside the pump is rapidly heating and it'll distort the internal mechanisms in the pump,
Yeah.
and it'll no longer work very well, if
Right.
at all.
And previously, you also mentioned we talked about it at the beginning. This idea of a bladder pressure tank just downstream of the pump, and I mean that's something that this the the manufacturer of the pump or the supplier of the pump is going to tell you if you need to put one in for that particular application in that particular pump. Correct?
Well, they
Or
should,
they
but
should. Mm-hmm.
our 30-year experience of the rainwater industry that
Mm-hmm.
it's normally rainwater people who are well informed that tell their pump supplier what they need. So
Mm.
uh, unless you've got a really good supplier, a pump supplier who understands rainwater harvesting, don't assume they know best about what you're trying to do, because our experience here, that's certainly not the case. Pump suppliers know about pumps, not about rainwater harvesting. So their product is the pump, which is a fairly generic process, which is quite different to rainwater harvesting, and you need to be aware of that. Or if you're not sure, you need to seek out a supplier that you know knows about rainwater harvesting, so they're better able to find the best pump for you.
Mm.
If not, this is why we're doing this course,
Mm-hmm.
we can sit down and work out what we need and why we need it for our particular house, and then we go and have the conversation with the pump supplier who knows more about pumps than rainwater harvesting. So, and that's probably the position we need to be in as rainwater harvesters. We need to be able to have an informed conversation with the pump supplier about what we need, and then we'll probably get what we really need.
Interesting. Interesting. Um, so then, despite variable speed pumps being slightly more expensive than single speed, that is something we'd recommend that students look for.
Oh,
Right.
absolutely.
Mm-hmm.
Bit more expensive to buy, but in the first year of operation, my variable speed pump used less than half the energy. That wasn't a lot of money, but but it was, a reasonable amount of greenhouse gas emissions that didn't come from my house. So
Mm-hmm.
they're not big numbers, but over a period of years they add up. So
Mm-hmm.
go for the variable speed pump if you can.
Yeah, and find a reputable supplier, buy a reliable pump, buy a quality pump, and again, you said it earlier. Choose the smallest pump that will actually work for the required household flow.
And this is quite an interesting um, dichotomy in philosophy. In the water supply industry, the utility supply industry, they always default to the biggest possible pump size. So just in case a peak flow comes along, um, and there's a long debate about whether or not that's a reasonable strategy, but not for here. In the rainwater industry, you want the opposite. You want the smallest pump that'll actually be adequate for your uses, because if you're going for larger and larger pumps, all that's happening is that pump energy is fighting with what you really need to happen in your house, and the outcome is quite high energy consumption, and it's not a linear process either. If your rainwater pump is far too big, you will have many magnitudes of more energy use than you should have. So we've been chatting all through this course about the concept of corrosion circuits. So if you've got contact between copper piping and an iron pump, you're obviously going to be creating some corrosion, and it'll be releasing copper and iron into the water supply. But even cast iron key components in your pump can actually increase the iron levels in your rainwater supply. So not really a health problem unless there's far too much of it, but just be aware of it.